Hi everyone, it's Mr. Fransky here. I'm actually coming to you from an airplane flying east right now, going out to New York. Our flight was quite delayed, so I was able to get all my stuff in order here and be able to set up the screencast for you. So if you hear the pilot or the flight attendants coming by, I'm sorry. But let's see if we can learn about 6.5 here while I'm sitting in my airplane seat. So on Friday, if you remember, we talked about going from vertex form to standard form. We did that with a box. We multiplied out some binomials, and we're able to switch into standard form. Today we're going to see if we can go the other way, if it's possible if we're given a standard form to go to vertex form. So let's start up with a warm-up problem here. This is what we did on Friday. So if you want to pause the video now and try this problem, what we're trying to do here is get from vertex to standard form. Remember, standard form is going to be ax squared plus bx plus c. So if you want to pause the video right now and try to see if you can get this into standard form, you can go ahead and do that. Alright, if you're back with me here, you can check your work, or if you decided to wait and do it with me, that's okay too. So remember, the first thing we do here, we already have the 4 on the left side. So what we're going to do, the first thing we're going to do is expand out this x plus 3 squared. Remember, x plus 3 squared means x plus 3 times x plus 3. It's tempting to distribute the 2 in here, or maybe distribute the squared to the x and the 3, but we can't do that. What we have to do here is expand out that binomial x plus 3 times x plus 3. So we're going to do that using a box. So make our box here. Try to make it big enough. We're going to have x plus 3 and x plus 3. So x times x is x squared. X times 3 is 3x. X times 3 is 3x again. And then 3 times 3 is 9. And now if I add everything here, I'll have x squared plus 3x and another 3x plus 9. Altogether, that gives me x squared plus 6x plus 9. Now that's just this part right here. So that's what I've found so far here. So I'm going to plug that into my equation. So right now I have y minus 4 is equal to 2 times this entire, polynomial. So 2 times x squared plus 6x plus 9. So now what I'm going to do is I'm going to distribute that 2 in here. So it's going to go to all 3 of those things. So I'll have y minus 4 is equal to 2x squared plus 12x plus 18. Then I'm going to add the 4. That'll be my last step, because my last step is to solve for y. 4's go away over here, and I just end up with y equals 2x squared plus 12x, in this case, it'd be plus 22. And now I have it in standard form. So that's what we were focusing on Friday, and then we said we wanted to label out a, b, and c. So my a value here is going to be whatever's in front of the x squared. So my a value here is 2, my b value is 12, and my c value is 22. That's going to be very important to label out that a, b, and c today. So make sure that after you get your standard form that you know how to find that a, b, and c. It's just the numbers. Remember, this is a no x zone. It's a no x zone. There should not be any x's in the a, b, and c. So we should just have a, b, and c as the numbers that we call these coefficients in front of the x values. Just for good measure, let's try one more of these. So this is similar to the last one. Once again, we're aiming to turn this into standard form. This is what we learned on Friday. And if you want to pause the video again here and try this one's a little bit different. Remember, this negative 2 we have to move. So why don't you pause the video here and just try this problem. Alright, welcome back. Hopefully you were able to try this problem. If you weren't, then you can work through it with me. So the first thing we're going to do here is we're going to add 2. So add 2 to both sides, because we want to get this into regular vertex form. So I'll have y plus 2, y plus 2 is equal to negative 3 times x minus 1 squared. Now the next thing we're going to do is expand out this x plus 1 squared. So I'm going to make a box for that. I have x minus 1, x minus 1, x times x is x squared, x times negative 1 is negative x again down here, and then I'll have negative 1 times negative 1, which is positive 1. If we add all that together, that's going to give me x squared minus x, that's going to give me negative 2x. Be careful you don't think those cancel, because we have a negative 1 and another negative 1 make a negative 2, and then plus 1 at the end. So that's just this x minus 1 squared. So now my equation is y plus 2 equals negative 3 times that entire polynomial right here. So x squared minus 2x plus 1. Now I'm going to distribute in that negative 3. Careful with that negative sign. So we're going to have y plus 2 equals negative 3x squared. Negative 3 times negative 2 is positive 6x, because I have an x there. And then negative 3 times 1 is going to be minus 3. Last step here is to subtract that 2 from both sides. And I end up with y equals negative 3x squared plus 6x minus 5. Once again, let's label out the a, b, and c here. A is negative 3. Notice it's not negative 3x squared. It's just the number in front. And then my b value here, whoops, keep doing that. My b value here is 6. And my c value is negative 5. So I got my a, b, and c value there. So now the question is, can we go backwards? If I'm given standard form here, is there a way to turn it into this form up here in vertex form? Well, one thing we need to remember when we ask this question, can we go backwards? Is it possible to go from standard to vertex form? So we have to remember, if we know the vertex, we can write out vertex form. Remember, the vertex form is just y minus the y coordinate equals x minus the x coordinate squared. So let's do that. So what we're going to do here is we're going to do y minus the y coordinate. So it's the opposite, is what you guys kept saying on Friday. So we'll have y plus 3 is equal to x minus 2 squared, because it's always the opposite. So we have positive 2 here, so it's a negative 2 here. Have a negative 3 here, so we change it to a positive 3 here. Now, the coefficient here, all we know is that it opens upward. Well, if it opens upward, we just need to make sure it's positive. So I'm just going to leave it like this. I'm just going to leave it blank. I'm just going to leave it as a positive 1 there. You could put a 3 there, or a 5, or a 1/2. As long as it's a positive number, it doesn't matter, because all we know is that we got our vertex of 2, negative 3, and that we have a positive number there, so it opens upward. So the moral of the story here is, if we know the vertex, we can put it into vertex form. And the cool thing is, there's a really quick way to get the vertex from standard form. So now, this is back to the question that we had from the bell work, actually, from the warm-up question. We were given this equation in vertex form, and we went to standard form. We got this 2x squared plus 12x plus 22. You can go back and look at that equation if you want to. But what we want to do now is say, is there some way to figure this out? Well, notice over here, our vertex is negative 3, 4. And that's a parabola that would open upwards because we have a positive 2 in front. But let's see if there's some way to figure out that vertex, if there's a way to get that vertex value. Well, there is. And what we're going to do is we're going to label out A, B, and C here. It's very important that you can find A, B, and C. A is 2, B is 12, and C is 22. So check this out. There's a lot of ways to prove why this is true, but they're kind of complicated. One of them involves completing the square, which is a little bit more advanced technique, and another involves taking the average of 2 quadratic formula values, which just sounds like a lot of fun. So what we can do is the x-coordinate of the vertex. Make sure you write this down. The x-coordinate of the vertex is negative b over 2a. So that negative b over 2a is going to give us this x-coordinate of the vertex. Let's see if that works. So we have our a, b, and c here. So let's do negative b over 2a. Well, negative b over 2a is going to be negative 12 divided by 2a. Well, that's 2 times 2, which is 4. So it's negative 12 over 4, which gives us negative 3. Hey, check it out. That's our x-coordinate of the vertex. That's pretty cool. So now we have the x-coordinate. You're saying, all right, Fransky, well, that's great. How do I get the y? Well, look at this formula that we have. If I know the x-coordinate, remember this is the x-coordinate of the vertex, then I can find the y-coordinate by just plugging it in for x. So then y is going to be 2 times our x-coordinate, negative 3 squared, plus 12 times our x-coordinate, which is negative 3, plus 22. So let's try it. Negative 3 squared is 9. So 2 times 9 is 18. 12 times negative 3 is negative 36. So I'm going to subtract 36 from that, and then I'm going to add 22. Well, 18 minus 36 is negative 18, plus 22 gives us a positive 4. Hey, that's cool. So we got our vertex. So we got our x-coordinate, we got our y-coordinate. I now know my vertex is at negative 3, 4. So right now I can put it into my vertex form. Y minus 4 is equal to x plus 3 squared. So now you're saying, wait, but what about that 2? How do we know how to get that number in front? You're going to love this. Remember we said vertex form is y minus k equals a times x minus h? Why do you think that's an a? Well, a is 2. All we do is just grab our a value, and we're done. So now I found a way that I can go from standard form to vertex form. That's pretty cool. Oops, I forgot my x squared right there. That should be squared. Good. All right, so let's go on and try another example here. So this is the other one, I think, from the bell work that we did. So we have 3x squared minus 24x plus 5, and what we want to do is be able to change this into vertex form. So first thing we're going to do is label out our a, b, and c. So label out our a, b, and c. A is 3 right here. It's just the number in front of the x squared. The b over here is negative 24. Careful to make sure that you get that negative in there, because it's negative 24. And then positive 5 is for c. So now to find the x-coordinate of the vertex, see if you remember what that formula is. It's the only formula we've learned in a while. So the x-coordinate for the vertex, remember it's negative b over 2a. This time our b is negative to begin with, so when we make it negative, it's going to become positive. So in this case, that's going to be negative 24 divided by 2 times a. So that's 2 times 3. That's going to give me positive 24 over 6, which is 4. So my vertex, I'm going to write my vertex over here. I know my x-coordinate is 4. So now remember, to get the y-coordinate, what do we have to do? Well, that's the x-coordinate, so I'm going to plug it in for x. So y is going to be equal to 3 times 4 squared minus 24 times 4 plus 5. 4 squared is 16 times 3 is 48. So we have 48 minus 24 times 4, oh boy, that's, I think, 96. So we're subtracting 96 there, and then we're adding 5. So 48 minus 96 is negative 48. Add 5 to that, and we get negative 43. So my y-coordinate is negative 43. It's a big number, but that's okay. We're just putting it into an equation, so it doesn't matter. So I have my vertex now, and so I'm going to put it into vertex form. So it's just y, and I subtract the y-coordinate, but the y-coordinate's negative, so it's going to be plus 43. It's going to be equal to, I'm going to put in my x minus 4 squared. Now remember how we get the number in front? How do we get that number in front? That's just the a value. It's just the a value. So I'm going to grab this 3 right here and just plop it in front of the x minus 4 squared. And now I have my vertex form, and that's all there is to it. That's it, to go from standard form to vertex form. Now, unfortunately, I'm going to run out of time here. I'm going to be cut off at 15 minutes. So if you're all set, if you understand what's been going on, you can go right to the worksheet. But do make sure you check Moodle. There's a second video on there if you want a couple more examples. And also there's a Movie Monday on there for you to watch. So be sure to check out Moodle. And remember that the solutions to your worksheet are on Moodle as well if you click on the green 6. So I'll see you in the next video in a couple seconds.